I built a very sturdy workbench for my CNC router assemblies, and I did it in less than 1 day just with a cordless drill. In this video I will show how it was possible to do it that quickly. And if you want to know the cost of the bench, watch till the end. Hello and welcome to my channel. I'm currently in the transition phase to establish a second workshop for the assembly of custom CNC routers, in addition to my home-based shop where I do all the machining. I'm also in the process to finish 2 customer builds, and those 2 tasks are somewhat time conflicting. So I started the assembly on an old table which happened to be available at the new site. But as you can see, this table very quickly reached its limits, and testing of the machines with dynamic movements would soon end in a disaster. That's why I had to get a new workbench, and I had to get it fast. I defined the requirements and they looked as follows. The table size 2 meter by 1 meter, work height of around 900 mm or more since I'm 6'4", movable but also lockable into a stationary position, capable to withstand a load of at least 1 metric ton, deflection under a max load of less than 1 mm, possibility to add tool drawers, and ready to rumble within 1 week. I looked around for commercially available workbenches, but none could meet all of these hard criteria. So the obvious choice was to build one by myself. One option could have been a wooden workbench in the Pausen style. I built one of these a few years ago for my woodworking shop at home, and I really like the design. But I don't have any woodworking tools at the new shop, so that's a hard no. Looking at the required load-bearing capacity, a welded steel frame was naturally a choice as well, but frankly speaking, I'm not much of a welder, and also I don't have a welding table. And to fabricate a straight and rectangle welded frame just on the floor without the possibility to clamp the profiles definitely exceeds my capabilities. And that's why I ended up with a frame out of extruded aluminium profiles. They are quickly to obtain, easy to work with, and offer the flexibility to change things later on. The downside is that they are bloody expensive. I went with ETEM compatible 80x80 profiles in the heavy duty version. And with the frame design I chose, the table only has a deflection of 0.5 mm when loaded with a metric ton right in the middle. That means for the stuff I normally build, there is basically no deflection or sagging at all. In the second step, I will add 2 drawer boxes to the table for all the tools that I need at the new site. But for now, I just needed the bench, and as I mentioned, I needed it quickly in order to move on with the CNC builds. I got the profiles from a local dealer, which I used for the first time. Price-wise, they were on the same level as my usual dealer, but they promised to deliver within a few days in contrast to a few weeks that I normally wait. At the end, it took them 7 working days to deliver. When the profiles arrived, I had some mixed feelings. On the plus side, they were perfectly straight, the various lengths were cut to exactly the same lengths, and clean cuts and no burrs. However, since they were labeled as construction profiles, they had plenty of stains and a few dings here and there. But nothing dramatic for a workbench, because I could hide them under the bench top or the bottom. For the connection of the profiles, I decided against angle brackets. Firstly, because I wanted to have a clean look, and secondly, because they are not the best connection to absorb vertical loads, since in the reality the joint between 2 profiles has no connection at all, and a downforce will introduce a bending moment in the bracket. One alternative are standard fastening sets, but they require a lot of preparation. Not only do you have to tap 4 M8 threads in each face of the profiles, so 112 in total in my case, but you also have to drill 112 perfectly aligned corresponding holes in the mating profiles in order to tighten the bolts. And that's why I went with the so-called automatic fastening sets. They are more expensive but require less work. All you have to do is tap them into the profile slots. In addition, they offer of all the connections the highest rigidity. In order to be able to move the workbench around, I went with these heavy-duty leveling casters. Each can carry 375 kilos, so theoretically I can load 1.5 tons on the bench. They have a small ratchet which moves the rubber foot up and down to make it stationary. Since the hole pattern is 70 by 70 mm versus the 40 by 40 in the profiles, I had to make 4 adapter plates. I used an old 20 mm thick offcut plate and let the CNC router do its magic. Nothing special, just a rectangular plate with 4 M8 countersunk holes and 4 M8 threads. The assembly of the frame is straightforward. At first I tapped 4 M8 threads into the vertical pillars to attach the adapter plates for the casters. To make that a little bit easier, I drill the extruded holes to the correct size. This is not always required, but these here were slightly undersized. Then I prepare all the other profiles, means I screw the cutting sleeves into the profile slots. That requires just a little bit of cutting paste and patience. Sometimes this process raises a burr on the profile, which I knock down with a file. One important step before preparing the second side is to add the screws, in this case M6 by 40 mm. Since they need to be tightened with a ball nose hex and the spec is 14 Nm, I went with 10.9 grade bolts. The final step of the preparation is to add the 76 mm long double T-nuts. Once all the profiles were prepared, I started the assembly. I built the frame directly on the Workbench top, since this is a clean and flat surface. The process is fairly self-explanatory, so I'll leave you a while with the video footage. The last thing to do was to attach the 27mm thick bench top to the frame. I did this with 12 M8 bolts and casted angle brackets. First, I had to add 12 threaded inserts to the beach plate. Then I added 12 brackets to the frame. But before that, I had to grind off the alignment pegs, which normally go into the profile slots. But because in this case the bracket is rotated by 90 degrees, they would sit prone on the pegs, and that's why I had to remove them. Another important point is to make sure that the slotted holes of the brackets are parallel to the long side of the beach plate, so it can expand and contract with temperature or humidity differences. And then it was finally time to move the CNC routers from the flimsy table to the sturdy workbench, so that I can finish their assembly. And while this footage runs in the background, let me summarize the total cost of the bench. First, we have the aluminium profiles, and they were 1,020 euros. Then the automatic Fastner sets, which were 184 euros. The M6x40 bolts and the remaining fasteners were 27 euros. The leveling casters were 64 euros. The beach bench top was 234 euros. And the oil wax was 23 euros. So in total, 1,550 euros, with the aluminium frame being 1,232 euros. The raw material for an equivalent 80x80x3mm steel tube frame would be roughly 750 euro cheaper, not counting the cost for powder coating or primer and paint. So in total, almost half of the cost. Yes, I know. But as I mentioned in the beginning, I don't really have the means to weld a straight and rectangular frame, let alone in one day, including grinding, welding, sanding, and painting. So my conclusion is, are there cheaper ways to build a workbench? Definitely yes. Was this method still the correct choice for me? Also a definitive yes. And that brings me to the end of the video. In the next one, I will show you how I assembled and completed the two CNC routers. If you don't want to miss that, subscribe to the channel and hit the notification bell. Also, please give this video a thumbs up if you liked it. Stay tuned and see you next.